In section 3.3, we're going to go over the derivative of trig functions, and this is simply a section that you're going to have to memorize. There is an entire proof as to why, and it uses the limit definition of a first derivative, the limit as h approaches 0 of f of x plus h minus f of x all over h. That goes into this, but we are just going to simply memorize the derivative of trig functions. So up at the top, you have all the different things involving trig that you should know. It'll just make your lives easier to know all of that information up there, but we're going to start with the derivative of trig functions. So when you're taking the derivative of sine, it's going to become cosine of x. Pretty easy. The derivative of secant is going to be secant x tangent x, and then the derivative of tangent is secant squared x. So if you have those memorized, the derivative of cosine, cosecant, and cotangent are pretty easy. Okay, so to start with, anything with a c, every single one of these, when you take the derivative of anything involving a c, it's always going to be negative. So the derivative of cosine is actually going to be negative sine. So these are the reverse of each other. Sine and cosine becomes each other, except for every time you take the derivative of cosine, because it starts with a c, it's going to be negative. The derivative of cosecant x is going to be negative cosecant x cotangent x, so really similar to secant, where it becomes secant tangent. And then the derivative of cotangent starts with a c, it's negative cosecant squared x, which you could have probably predicted given that the derivative of tangent is secant squared. This box you have to memorize. Expect a quiz on this content. You will definitely have a quiz. Straight memorization. In number 1, if we were to evaluate, this is the limit definition of a first derivative. You should recognize this format and notice where f of x is. If you've identified what f of x is, all this evaluate the limit as h approaches 0 of tangent x plus h minus tangent x all over h. If you know what that is, they really just want you to take a derivative. So we can go ahead and find the derivative of tangent, and that is secant squared x. So if you have these memorized, then it's pretty easy to just go through derivative problems. So the derivative of 2 cosine x minus 3 sine x, we're going to drop down the constant in the front 2, and then when we take the derivative of cosine, it's actually negative, right? Starts with c, it's negative sine x, and then once again you're going to drop down the minus 3, and we take the derivative of sine, it's cosine x. So really we have negative 2 sine x minus 3 cosine x. In number 3, take the derivative. So we've got f prime of x. The derivative of is secant x tangent x. Drop down the plus sign, the derivative of tangent, secant squared x. This is a time when secant squared can be written like that, or it's the same as secant x quantity squared if you're typing that in your calculator at all for any reason. Number 4, we're going to take the derivative. So we've got f prime of x, drop down the constant, and then the derivative of cosecant, it starts with the c, it's going to be negative cosecant cotangent, and then the derivative of minus 5, it's going to be 0, right? You're taking the derivative of the constant. You don't actually have to put that. Our final answer is just simply negative 4 cosecant cotangent. In number 5, we've got to take the derivative of x squared cosine x. Right here, we have one function, and then we also have cosine x, which is another function. So we're going to be doing some product rule because we've got two different functions right here. So we're going to take the derivative of the first multiplied by the second plus the derivative of the second, which is negative, c's are negative, multiplied by the first. I like to move the polynomial to the front of whatever I've got. So I'm going to keep this as 2x cosine x, and then that's going to be minus x squared sine x. It's just easier for me to see, and then I'm not trying to do x times x squared, which is not possible. You cannot multiply those together. In number 6, secant tangent is not one of the problems in the box. They are, however, separate problems, all right, separate derivatives. So right here, this is an indication of we've got the first and then we've got the second. So to find f prime of x, we're going to take the derivative of the first, the derivative of secant x is secant x tangent x, and we're going to multiply it by the second. It's product rule, so we've got plus the derivative of the second times the first. So for this, we can go ahead and multiply tangent and tangent to get tangent squared. So we've got secant x tangent squared x plus, and then secant squared times secant is secant cubed x. All right, numbers 7 and 8, there are a couple different ways that you could solve this. So I've put the different methods out there for you. For number 7, they did quotient rule. We can label the numerator and denominator, and they took the derivative of the numerator times the denominator minus the derivative of the denominator times the numerator all over your denominator squared. It's a really long way to do it, but you eventually end up with secant squared. We, however, can change the y from 1 over cotangent to be just tangent. That's equivalent. 1 over cotangent is tangent. So when we take the derivative of tangent is just, as we've memorized, secant squared x. In number 8, they went through kind of the same process. They used quotient rule in method 1 because they took the derivative of the numerator times the denominator minus the derivative of the denominator times the numerator all over to the denominator squared. Really long way to get it, but they got to the answer of negative cosecant x cotangent x. Now, in method 2, they did secant times 1 over tangent, and 1 over tangent is just cotangent. So they did product rule, the derivative of the first times the second plus the derivative of the second times the first. They ended up with the exact same answer, which is still correct, but we can use method 3, and that is to take the function and fully simplify it to start with. So secant is really 1 over cosine x, and then divided by tangent is sine x over cosine x. Use your fraction rules. We've got 1 over cosine x times, flip the denominator, cosine x over sine x. I can cancel out my cosines. 1 over sine is just cosecant x. So f of x is really just cosecant x. And then we can go ahead and find the derivative. It starts with the c, so it's negative. All c's are negative. And as we've memorized, the derivative of cosecant negative, cosecant x cotangent x, which is exactly the same as the previous 2 methods. That's our final answer. Expect a quiz on memorizing your trig derivatives and have fun with these.